Supersize Me is the title of a documentary film about what happens if you eat only McDonald's for a month. And it's also the title of this talk. So we're going to take a look at natural language processing, which is a very promising field in data science, particularly since 2018. So in October, Google released their BERT model, which represented a groundbreaking achievement as it was built on transformer architecture and it incorporated a number of other advancements and really just broke every single benchmark that had been laid down in the field previously. So since October 2018, the performance of machine learning models has continued to improve by leaps and bounds. And yet, innovation into that underlying transformer architecture that was introduced by Google's BERT seems to have stagnated. So the performance benefits that we're seeing are just really due to supersizing the models, just creating bigger and bigger models with more and more compute. So coming in at 175 billion parameters, GPT-3 is the latest entry in this string of supersized models. In this talk, we're going to be looking at some of its capabilities, but also some of its limitations. And most importantly, I want to address the impact that this avenue of exploration on progress towards the ultimate goal of creating an artificial general intelligence. Okay, so GPT-3 came out in May of this year. It's capable of some pretty impressive and some perhaps spooky NLP feats, such as writing documents and poetry. It can do question answering. It can also solve math problems. And it even writes code. AI philosopher Joshua Bach says that it babbles at the level of a human non-expert. And this has even led some observers to question the potential obsolescence of certain professions, including software development. But I'm not so sure that that's really going to be something that we need to worry about anytime soon. Really, the code that comes out of GPT-3, it requires a lot of human review before it can really be used. And then it's also worth noting that GPT-3, it hasn't been publicly open sourced, and it's in fact available through an API with an extensive waiting list. So before we talk a bit more about the impact of NLP deep learning on society, let's discuss the creation of GPT-3 in more detail. So the training of this model entailed 4.6 million USD in compute costs. This is the equivalent of 355 GPU years using NVIDIA's most powerful GPU. And the effect of this training is roughly equivalent to the lifetime emissions of 5 or more cars. And that figure, it refers just to the training costs. So that's not including the cost of R&D or inference. Okay, so why is there so much hype about this model? Stuart Russell, who is the head of the Center for Human-Compatible Artificial Intelligence at UC Berkeley, summarizes the situation as follows. Artificial general intelligence is not going to be reached by just having a bigger deep learning network and more data. I don't think deep learning evolves into AGI. So theoretically, if AGI is the goal of your machine learning research, just throwing more compute at the problem, it's not promoting breakthroughs that will create this step function increase, the way that Google's BERT was so innovative and new in its architecture. So it's pretty clear that I take a skeptical tact towards evaluating these latest advancements in NLP. I think there are 3 problems here. The first is that the cost to train these models, it's quite unsustainable. Very few companies would be able to enter this space. And it really limits what can be achieved to a subset of well-funded organizations. Second, GPT-3 hasn't been publicly released, so it's difficult to audit or to learn from it more broadly. And then third, we've talked about how this model is potentially distracting from the ultimate goal of pursuing AGI, which is also research that the parent company, OpenAI, has been actively involved in. In terms of where we're going from here, there's speculation that OpenAI, which produced GPT-3, as well as comparator organizations such as DeepMind and AWS, are going to continue to compete to pursue bigger and bigger models because of all of the hype that surrounds these state-of-the-art advancements. And the underlying rationale for the pursuit of these supersized models is profit. All of these companies stand to profit from the paradigm of GPU-based training. But what if supersizing machine learning models isn't the only path forward? What if there's a way to democratize machine learning and achieve innovation at a faster rate? Okay, so based on my understanding of the field, I'm seeing an orthogonal movement towards the development of smaller and more nimble machine learning frameworks, as well as associated computing hardware. Promising alternatives to the Supersize Me approach include the lottery ticket hypothesis. This is where fortuitously initialized neural networks are sort of found within a sufficiently parameterized network. Another option is the redesign of algorithms for commodity CPUs. So it's not necessarily the case that machine learning has to be done on GPUs. In fact, perhaps it can even be done on a Raspberry Pi. Bigger is not necessarily better. So it really just depends on our goals for the field of machine learning and for perhaps the ultimate goal of artificial general intelligence. All right, so that's it. That was 7 minutes. This is my resources slide for additional things that you might look into. You can check this talk out later. It's really great. And then the article that I'm writing on this topic is called "Can We Kill Artificial Intelligence?" Because I think that term is kind of misleading the way that it's currently applied to data science initiatives. And that's it. All right, so at this point, I'm going to stop sharing my screen. If people just want to jump in, unmute themselves and ask, since we don't have ratings for these questions yet.
I'll go ahead and ask, do you have any good resources like you could link us to for results of using some sort of pruning or model distilling for those big NLP models? I mean, I know that there's like smaller versions of BERT and stuff out there, but I don't think I've ever seen like metrics for how they perform.
Yeah, right. That's a great question. I will say I'm unqualified to answer that sufficiently because I have personally never pruned. However, I will say that I've heard that NLP models can be pruned up to 60% and still achieve the same performance as the original model. So that's like really crazy. It's the idea that you can take a neural network and just at the end, after you've trained it, you can just remove 60% of the weights and the model performance will stay exactly the same when you use it again. So that's like a really interesting kind of fact about machine learning. And then what was the other question? I feel like there was another component to your question. Or perhaps it's just the fact that I wanted to share actually for image recognition models, the extent to which you can sparsify the model is even greater. So you can drop out 90% of connections in an image recognition model. So that's like kind of blows my mind.
Wow, that's huge.
Yeah. Okay, cool. Okay, so one other question.
So I guess kind of the implication you were making there, though, was that a lot of the hype, like to some sense, they're kind of like maybe not stagnating, but like slowing the releases of like big leaps and downs versus like just making it bigger, because then Google gets to sell more compute time to people who like may want to train their own BERT, may want to train their own GPT-2. Same with like AWS, I imagine as well.
Yeah, it's like there's no financial incentive for saying we can streamline these models, we can make them easier to run with less compute, we can put them on a tiny ML, a little microprocessor chip, and you can do FPGA coding at home. Like they're not making any money, but if there's this whole hype cycle that's built up around like, oh my gosh, look, we like broke a benchmark by 0.0001%, but it's now we have the new state of the art. They stand to make money. So I think that I'm like very skeptical. Obviously, a lot of people are really, really excited about these models. So I just wanted to put forward an alternative view.
Just like that, not very democratized, which like hinders like kind of the growth to some extent.
I think so.